Hey students, in this video I'm going to go over how to solve rational equations. But the steps that you see right here are what we're going to follow, and some apply to all and some don't. So let's just be open-minded to skipping some steps as we go. Whenever you are asked to solve equations, pretty much you need to understand that you are given an expression that equals another expression. So any changes that you do to one side of the equal sign, you also have to apply to the other. So it's pretty much going back to you using your skills that you learned back since 6th grade to solve equations. Here we're going to ask ourselves to factor first. Can we factor the numerator and denominators that were given? In this first example, we have 6, 5x, and 4. These are technically monomials, so they are just not merged with any other term, so just one term each. And if you look at the factors, they cannot break more. I'm going to turn to the back so you can see how these are expressions that we can GCF. Both of these have something in common that we could divide by. And then also down here, we have these where it's a trinomial. We could factor that. This is a difference of squares, and we can factor that. So on this example, there's nothing to factor. Next, we're going to determine restrictions, determine the values that make the denominator equal to 0. These values cannot be solutions. So if we go down the list here, we have factors, check, restrictions is next. This is where you think of the denominator equaling to 0, and you ask yourself, like, how can this become 0? Well, you grab your denominator, you equal it to 0, and then you solve. So 5x means 5 times x, which means that we need to isolate the x by dividing by 5. Inverse operations. So here, this 5 over 5 becomes a 1-to-1 ratio, so x equals, and 0 divided by 5 is 0. So this is the value of x that can make the denominator a 0. So we're just going to say that the restriction here is that x cannot equal 0. All right, check. Next, we have combined fractions, meaning sometimes each side of our equation may have more than one fraction, so you need to combine. So for example, the one we have here is one fraction on the left side, and technically one fraction on the right side as well, since 4 is 4 over 1. But for example, back here, we have this one that has two fractions on the left side. So that one is requiring you to sort of ignore the right side and then just merge those two technically by adding, applying the skills that you have learned about adding rational expressions. And then once you have an answer, then you can replace it by that space and then solve the equation. So let's continue on the steps here. We're going to now cross multiply. Cross multiply to create a new equation with no fractions. So the example I gave in class was for proportions. When you were taught proportions, you were given two fractions that are side by side with an equal sign in between. So here, for example, 2/3 and 8/12, you were asked to check if these were proportional. So one way you will check is by multiplying across. 3 times 4 is, 3 times 8 is 24. And then multiplying this way across, this is 2 times 12, which is also 24. And if these two numbers were the same number, then these two fractions were proportional. Therefore, we're going to apply the same math concept here. When we multiply the denominator times the numerator of the other fraction, so for example, 5x times 4, it should equal the numerator of this fraction times the denominator of the other fraction. So it's just a fact. It works in any mathematical problem. Next, we're going to simplify this part and we're going to just multiply. 5x times 4, that gives you 20x. 6 times 1, that's 6. This is the one-step equation where we just divide by 20, since 20 is a coefficient next to x, and we want to get rid of it as a 20. 20 over 20 is 1. So that's where we end up with x. What we do to one side, we got to do to the other. So we end up with 6 over 20. But 6 over 20 can be simplified by 2. So when it's simplified by 2, we're going to say that x equals 3 over 10. Let's try another example. We have these two fractions, similar to the previous one, where we check if there's any factors. And nope, all of them are okay. This is a binomial, but it's still just one factor. Binomial, one factor. Next, we're going to do restrictions. And this is where you look at the factors that you have as denominators. And you equal them to 0. Next, we find out what x value will make this a 0. And some of you can just look at it and already know. I'll just go ahead and do the math behind it. So we do inverse operations. We cancel the 5s, and x equals positive 5. But remember, these are restrictions, so x cannot equal positive 5. And the last one, we have x plus 3, so minus 3 on both sides. And x cannot equal negative 3. So next, we are going to cross multiply. We'll just use a different color. Cross multiply. So we have 5 times x minus 5. And then we have 10 times x plus 3. So here we have an equation where you need to distribute in order to be able to solve for x. We're going to distribute, we get 5x minus 25 equals 10x plus 30. Then this is where you make a decision of where you want your x's and your constants, your variables or your constants. All this past, we are going to switch, I guess. It doesn't matter. I'll just move the 10 this side. Most of you like to have the x on the left side. All right, we'll move the numbers to the right side. So the number on the left side is gone. Now let's see what's left. 5 minus 10, that's negative 5, and then it's x. So 5x minus 10x is negative 5x. Over here, we cancel the 10, so we're just 30 plus 25. That's 55. And then to finalize this question, we just divide by 5, negative 5. So x equals negative 11. All right, I'm going to only do the examples on the left side, and then that way you can practice the ones on the right side. So here we have an expression where 2 over x plus 6 is already factored. X minus 6 is already factored. So this is the part we got to factor a little bit. In class, most of the students were saying 3 right away. 3 is the number you can divide both by. And they were also thinking of the x because they both have x's. So 3x times x will give you 3x squared. And 3x times positive 6 will give you positive 18x. But we want a negative 3x, so that means that we need to change a couple of things. If we put the negative in here, that's going to look different than we have seen before. So let's just keep the negative out here. We're going to divide these by negative 3, which means we are actually going to change this plus sign into a minus sign. So we're dividing by negative. Negative divided by negative is positive. Well, actually, no. That's what we want. We want the negative. Sorry. All right. So these are the factors for this trinomial. And now we just look across and we do restrictions. So restrictions for here, we are actually going to have several. X minus 6 is or x plus 6 is a factor. X minus 6 is also a factor, and then negative 3x is a factor. To solve for these, we just apply inverse operations, so minus 6 x equals negative 6. On this one, plus 6 plus 6, x equals 6. And then the last one, we have negative 3x equals 0. And if you may recall from the beginning, when we had 5x here, we're going to also apply it here, where we divide by negative 3, which ends up with x equals 0. Or you could just see it as negative 3 times 0 is 0. All right, 3 restrictions found. To solve for this, we're going to go ahead and cross multiply these two and those two. So 2 times negative 3x times x minus 6 equals x plus 6, x minus 6. And then here you may notice that x minus 6 is on both sides. So once again, we want to keep it equal. So if he wants to go, I guess he has to also go. And now we have 2 times negative 3x, negative 6x in total, and x plus 6 on this side. So to solve for x, we need to isolate the x and move it around. This x needs to go, so minus x on both sides. And then we have negative 7x equals 6. So we divide by negative 7. So x equals 6 over negative 7. Or negative 6 over 7. Or negative 6 over 7. So it's 3 different ways to write this down. All right, the next part, I'm going to try to speed it up if you want to rewind as needed. But just to make this video a little shorter. Or actually, I'll just do part 2 for these two because they are going to be a little lengthy. Okay, so if you want to watch these, go ahead and watch part 2 of the video.